Hello, everyone, and thank you for joining us today. I'm David Nunez, Director of Metadata and Digital Platforms at Baker Library at the Harvard Business School. And I'm here with my colleague Aaron Wise, Associate Director of Information Management. Today, we're excited to share our perspectives on knowledge graphs and semantic search, two technologies that are transforming how we approach data connectivity, quality, and increasingly, AI-driven discovery. We'll be walking through why these technologies matter in a library context and how our team at HBS is putting them into practice. Let me begin with a little bit of context about our group, MKS, short for Metadata and Knowledge Systems. We are a hybrid technical information management and administrative team housed within Baker Library. Our unique focus has been to address the data and infrastructure needs that support the day-to-day operations of the institution, rather than only servicing purely public-facing or research-specific systems. We often find ourselves translating between library and IT cultures, between metadata standards and enterprise applications, working to ensure that information flows in meaningful, structured ways. This interdisciplinary approach has helped us see just how essential it is to bridge disconnected systems and data silos, especially as we support increasingly AI-driven services. As many of you know, academic institutions often face challenges with fragmented data. Information lives in different systems, managed by different teams, and often lacks consistent identifiers or structure. A Gartner statistic from 2021 says that in 2025, 80% of enterprise data is unstructured. An IDC research white paper from last fall highlights that 90% of enterprise data is unstructured. In our role at Baker Library, we get operational questions about data from across the HBS enterprise that were once very difficult to answer because the various data sources were not tied together with any structure at all. However, our team has been working strategically on this fragmentation problem for many, many years, evolving our tools and workflows to be of better service to our colleagues to working on their actual use cases. With this long-term focus on building a solid data foundation, we are now well poised to take on the challenges of emerging technologies like large language models to provide a new generation of insights. All of us in this room understand that unstructured, siloed data complicates discovery and insight. We're also learning that data fragmentation actively undermines the effectiveness of AI tools that depend on high-quality integrated data. Recent research highlights that disconnected and unstructured data can lead to inaccurate or hallucinated outputs from large language models. Grounding AI tools in structured data, such as knowledge graphs, significantly improves response accuracy and mitigates hallucinations. A 2023 review of scholarly knowledge graphs points out that one of the key challenges in research communication is the lack of structured, machine-actionable metadata across scholarly records. This limits discoverability and reduces the potential for AI-powered insights. And this pattern holds in enterprise environments as well. In a 2023 benchmark, knowledge graphs boosted the accuracy of AI-generated answers by nearly 3 times. And in fact, AI systems without knowledge graph support failed completely on complex schema-intensive queries. And these findings underscore a simple truth. AI is only as good as its underlying data structures, data architecture. I should mention, at the heart of what we're building with this architecture is data governance. We're involved in a campus-wide initiative to define roles, responsibilities, and policies that support trustworthy, high-quality data. It's very early days, but Baker Library has been helping to lead efforts to establish metadata standards and best practices, focusing not just on control, but also on sustainability and usability. So by investing in governance, HBS is not just organizing data, we're also laying the foundation for more intelligent, automated systems across the academic landscape that integrates the complex realities of collaboration and data sharing among stakeholders. This brings us to the core of our work, the knowledge graph. Knowledge graphs allow us to express entities like people, organizations, research outputs, and concepts, and the relationships between them in a structured, interconnected way. It's this structure that provides the semantic richness needed for both improved discovery and AI readiness. In our work at HBS, we built a knowledge graph to connect previously siloed systems, including data about publications and researcher profiles, into a unified searchable network. This not only improved internal workflows and discovery tools, but also laid the foundation for the next generation of improvements in our long-standing semantic search infrastructure, and will help us innovate on future AI-powered applications. A study shows that this is a very critical step. Traditional keyword search is insufficient to provide accurate responses, and knowledge graphs enable systems to understand user intent and semantic context more effectively. These priorities align with the work of the ARL CNI Task Force on AI Future Scenarios, which outlines strategic directions for how research libraries should prepare for an AI-driven future. While their scenarios don't specifically single out knowledge graphs, they do emphasize that the success of AI applications depends heavily on data integrity, provenance, and persistent infrastructure. These are precisely the qualities that knowledge graphs help deliver. By organizing information semantically and capturing relationships explicitly, knowledge graphs serves as a backbone for responsible and reliable AI integration in libraries. In other words, if libraries are to remain trusted intermediaries in the scholarly knowledge ecosystem, knowledge graphs may well be a critical part of that infrastructure and offer improved explainability, reliability, and query performance. Our project, HBS Knowledge, advances the thesis that well-structured, uniquely identified data is essential to any AI initiative. In fact, without that structure, the outputs of even the most advanced AI tools become unreliable and untrustworthy. So with that, I'll turn it over to Erin, who will share the implementation story from our HBS project.
I will talk a little bit about what we did and why we did it and how we did it. So first of all, just to describe what HBS Knowledge is. So we saw it very much as a solution to a very specific problem that we were seeing with the partners that we worked with when we were doing our metadata and taxonomy work. So David mentioned that we serve often we serve an internal group, so we work with other administrative groups at the business school, and we're very intimately familiar with their challenges with data and with the data silos at HBS, and we've helped them over the years. We've done a lot of work with them to help them organize their information and help them find information from other repositories on campus. So our specific goal was to provide a single source of truth for descriptions of HBS resources, in particular people, companies, and publications. Those are the ones we started with. We later added courses and some other types of content that we wanted to bring in to extend our graph. So we scoped it to people, companies, and publications because these are the things that are most frequently data is most frequently sought about them at HBS. We thought that a knowledge graph would be a great solution for this particular challenge because it would allow us to integrate the way data was described across different silos at HBS. So we wanted to try a knowledge graph. We wanted to use a semantic search application, and we wanted to leverage the vocabularies that we create and that we manage in the library. So this is a very brief history. It makes it look very simple and clean. It was not. So in 2021, we launched a proof of concept product to show to the community. And that was actually a really fortuitous timing because it coincided with the publication of a report by the Digital Transformation Task Force. So there was an effort with the dean of Harvard Business School to start digital transformation at HBS. And so there was a lot of analysis and interest in data and how best to use data at HBS. So it was pure kismet that we launched at the same time that report came out. So there was a lot of interest from the community. So we did roadshows. We talked to anyone who would listen about what we were doing and how we thought it would help HBS. So 2021 was mostly focused on communicating out to the community. 2022 and 23, we focused on expanding the graph that we had launched with, and that was based in part on the partnerships that we established with the community. So when we were going around talking to folks at the business school, it sparked a lot of ideas. So people were very interested and thought, oh, maybe you could help us create something to help us pull together all the different types of information that we're wanting to show. 2024, we positioned ourselves as part of an HBS web redesign project. So the business school was redesigning all of its public-facing websites, and we got in there, even though right now our website is not public-facing yet. So that is because part of the data that we curate is not necessarily open to the public. So we have information about alumni, for example, and we can't share that. So our site is currently behind HBS login, but we are now designed along with the rest of HBS web properties. And just last month, we launched the redesigned site. So that's what we're giving a peek at here. So just some definitions. What is a knowledge graph? We talk about it as a structured model of a domain. In our case, we're modeled specifically the HBS domain of business. So business as practiced as at HBS. We were very specific about what we were trying to do. And we organized it as a network of entities and relationships. It provides a common structure for data and enables us to create complex relationships across multiple data repositories. We have a flexible schema that can evolve over time. So as we introduce new content and new content sources, we can just continue to add, we can just continue to define what we want to be able to say about those things. It supports reasoning and inferencing, so we can find implicit connections even when they aren't explicitly coded in the data or explicitly stated by us. And it provides us with an entity-centric view. So one of the goals was to be able to provide entity-centric views. Tell me everything I need to know about this company's relationship with the Harvard Business School, for example. And companies are a big desirable thing at Harvard Business School, so it's always important to know what's going on with them. So semantic search, what we launched with was reusing our vocabularies and our ontologies to capture relationships among words. So we haven't dipped into vector search yet, which is another way of getting at that, but we specifically use the vocabularies that we curate because we've been doing it over time. We're very familiar with HBS and can help guide users in their search to specifically what we think they're looking for at HBS. So we used our vocabularies and our ontology to capture relationships. The example here is Anthony Mayo. It's a simple example, but Anthony Mayo is a faculty member. He is identified as a person and as a faculty in our ontology. He has multiple, pen names. So you can search for his various alternate names and still find Anthony Mayo. We always know that what you're looking for is Anthony Mayo. Another example would be the relationship between like Dubai and United Arab Emirates. So if you search for Dubai, you'll find content that's also we're serving up content about United Arab Emirates, even though the Dubai search isn't present in that content. So it's understanding the intent and the relationships. It's understanding the intent of the user and the relationships among our vocabularies. So the way into the graph is through search. So we offer search suggestions, and we have suggestions for company names and topics, which are managed specifically by the library. We also are using and reusing school and university entities, so the HBS faculty names, the HBS alumni names, names of courses. Initiatives are sort of topic-focused areas at the school. So healthcare is one, business history is another. So they're just specific areas that try to promote the work of the school around that topic. So all the courses about healthcare, all the faculty who write about healthcare, all the publications about healthcare. So healthcare is the focus. And then course material, we also got our hands into. We did have to take a step. So part of the metadata fund was, once we collected all this data, trying to understand how to present it. And so for alumni in particular, I just wanted to mention there was an effort to disambiguate alumni. There are many, many, many John Smiths who are alumni of HBS, and we had to disambiguate them somehow in the suggestions so people would be able to tell which John Smith they might want to look at. And so we appended metadata about the alumni to their names so that they could be disambiguated. So this is an example of the site. So we have these entity-centric pages. This is a look at Apple Inc. At the top is metadata about Apple. And then as you scroll down the page, you get, and I can't show, there's not enough space to show the whole page here, but so each of those rows, you're looking at faculty publications, but then if you keep scrolling down, you see a row for the alumni who are currently employed by Apple, and then faculty who have written about Apple, and so on. So for each entity, we're showing metadata about the entity and then the related entities that pertain to them. This is a little video demo. And so we're searching, and we're searching for Apple. We can't show alumni names. We can scroll down and find Apple Inc. Again, this is the metadata, and then we can scroll down and see the various related entities. Faculty, we can click on one of those faculty members and then get to his page and start scrolling down to see what's related to him. So how we did it. We selected HBS entity types and content sources, and that was actually really hard to do. So there were so many things that we wanted to do. It was kind of a challenge to restrict ourselves to only a few, but we were adamant and we stuck with people, publications, and organizations. And among those types of content, we stuck with only a few sources. So first we identified the content that we wanted to model, and then we chose the sources that we wanted to get the content from and the metadata. So we had a faculty and research website, which contains a lot of the faculty publications. We have an HBS Working Knowledge publication, which is housed in the library. The library puts out this Working Knowledge publication, and it highlights faculty research. So it's articles about the faculty research, it's interviews about the faculty research. And then we also had data from external relations, so that's where the alumni came in. We modeled our domain with an ontology, so we identified the classes and the attributes and the relationships that we wanted to capture. We minted URIs for each of the specific entities we wanted to uniquely identify. We converted our data to RDF triples and ingested those triples into our triple store, which is RDF for J. And then we ingested all that into Solr for front-end discovery. And the triples is just a simple, nice and simple sentence structure, subjects, predicates, and objects. So we could say Amy Edmondson is the author of Teaming Up to Win the Rail Deal. And then we turn those, we mint URIs for the subject and the object. And so that turns into this long URI string. but it's quite simple, and it's flexible. We can just continue to add statements as we like. So next steps, there's still much that we would like to do. So we want to, as David alluded to, we want to leverage our graph to aid search and retrieval. So for example, we want to start looking at graph RAG, retrieval, augmented generation, so that LLMs can be grounded in what we know to be true and what we've specifically stated to be true in our graph. We think there are strong possibilities there. We would like to experiment with scoped graph implementations. So we did that a little bit. And this is based on the fact that there were so many people who are interested, like the initiatives who wanted to gather everything around a topic. So we're looking at the possibility of maybe we could help people as a metadata, just kind of add that onto our metadata services and help people structure their information and their data into a graph. We also have the working knowledge folks, which is the picture that I'm showing here. That's the working knowledge search page. They had the brilliant idea to use some of our graph nodes in their search implementation. So they wanted to take what we've done with the graph and embed it in their website. So that's a possibility too. Perhaps there are other web properties that we could embed our data into. And we definitely want to start presenting the graph as interactive visuals of nodes and edges, because one of the first things that we did when we did our road shows in 2021, the first question we got was, well, why didn't you do this as an interactive graph with nodes and edges? And part of it was because we didn't have the right technology at the time. But also, I mean, we are, the sort of flattened view of the graph is still a view of the graph, and it's similar. It's like a Google type implementation of graph data, and we wanted to show it together with search results. But we do definitely want to provide a way to just navigate the graph itself. So we learned a lot of lessons. The first lesson, we knew almost immediately as soon as we launched the POC, that if we wanted to scale, we couldn't do it alone. We need partners. And we have developed quite a close collaboration with our IT department. And that's been great. So one of the things that we've been doing with them is what we call our Baker architecture modernization. So the idea was that the things that Baker was trying to do could be beneficial to the rest of the school, and IT is working with us to help bring that to the rest of the school. We need to automate wherever we can, obviously. So especially around the ETL processes, there was quite a bit of manual work, especially upfront. The upfront work is analyzing what you have and trying to figure out what you care about and what you want to show and how it all fits together. So that was a challenge upfront, but now we're sort of looking to make it a little more push button. So once it's all, as long as the source doesn't change too much, then we can do this more systematically. Data flow and data ownership and permissions across the school is important. Am I running out of time? Did I over? Okay. Okay, I'll finish up. So I guess I'll highlight data governance and architecture. David alluded to this also in his part of the talk, but what we need is systematic access to data, and we were not in a position when we started this in 2021. We were sort of scrabbling for data and trying to get it however we could. And basically it meant going to specific departments and asking them for access to their data, and then we could get a feed or a data dump. But really we want to make it much more systematic. That's the only way that this is scalable. we want to collect data as close to the source of record and ownership as possible so that we're not creating interpretations of interpretations. And graph is only as good as your source data. It's probably a pretty self-explanatory one. And the best lesson of all was if you have an idea, try it. So we did this with very few resources. And I think maybe the fact that we were doing this during the pandemic might have had something to do with it. But we were basically, there were four of us trying to make this happen. And we were using freeware wherever we could. The greatest resource that we had was the gift of time. So we did have support from leadership, which was wonderful. And time was really the main thing. And we did it in about 3 months, beginning to end. So four of us sort of making all this happen once we scaled down, and we were pretty ruthless about kind of, slash and burn just so we could get something out pretty quickly. So if you have an idea, try it. I feel like we got a lot of traction out of this work. So the fun thing was that we were taking library strengths, things that we do naturally and things that we enjoy doing anyway, and we were applying it to digital strategy for information discovery. The second big component of that was that we had very active engagement with our community. So we had built up a user base already through the services that we provide, and we had a very kind of eager community to talk to, and that resulted in really great strategic benefits for us. So I think it got us into maybe some conversations that we might not have been in otherwise. So for example, around digital transformation and also around governance. So I think it gave us some street cred there. Okay, that's it. Thank you, and we're happy to take questions.
I think
I
think we have like 2 minutes for questions. And
Hi. I was just curious, did you consider I see that you created your own ontology. Did you explore existing ontologies and discard that for a reason? Did you not find one that you needed, or?
We like schema.org, actually, ontologies, but we didn't have a ready-made ontology that we wanted to just take, but we definitely referred to schema.org a lot and sort of tweaked it to our own uses.
Can I ask a question while going to the mic?
Yes.
So thank you I think I understand the semantic graph and how that could enrich search. Can you describe a little bit more how you're leveraging AI, either producing the graph or to get better AI?
do you want to take it? Well, the answer is not yet. So I think that the point of our discussion today is really, this is foundational. There's definitely stuff happening across campus. People are going rogue. They're making their chatbots. They're doing the stuff, and it's very exciting times. But we have the core thesis that we need structured data to do this well, to provide better results, et cetera, et cetera. Is that a fair answer?
Yeah.
Yep. Yeah.
For the recording, the question was, how are we using AI?
Can I ask one more question?
Please.
Without the microphone?
Sure.
So it looks like most of the entities you're mapping are ones around HBS, not the full text of, say, journals or case studies.
Fine.
How are you bridging that? Are people interested in both, or you're just searching? I would expect most people would say, what's the literature or what resources are there, not just who's at HBS that's done this work. And
You want to take that?
Yeah.
Yeah.
So
Repeat the question, too.
okay, so I think the question is, how are we integrating or incorporating the publications and the data that researchers are interested in, as opposed to just the who's at HBS and so it's a great question, and it's where we want to start turning our attention next. So as mentioned, we sort of initially set out to do this as an internal tool. So, which is why it's behind Login. It's an internal tool based on the people that we work with a lot at the school. So it was specifically meant to answer the questions that we would get from the dean's office, for example, that we couldn't easily answer, like what cases are you teaching in these courses? But ideally, we need to start branching out, and we do want to make, I think I forgot to say this, but we do want to make a public version available, which means that we have to start incorporating different data that we can't, because right now we have data that we cannot show to the public because it's meant for HBS, but we need to start thinking about how this is helpful to our researchers and not just, the domain of, how we practice business at HBS. So that's part of what's next. I mean, it's the data, it's the technology, it's the UI. All of those things are, places that we want to go, but now we need more than 4 people to do it.
I think we're at time, but our emails are there. Please reach out and find us around. We're happy to talk more. Thank you so much.